We are going to do more part and part design today. And so we have a number of things to look at. Let's see. Uh, okay. So goals of the 3D modeling course, modeling and design course. What I'm saying now shouldn't be necessary, but it has been made necessary by some of the questions that you have asked in the chat room. Because of those questions in the chat room, it has become necessary to reiterate the goals of this course so that you know precisely what we are after. Some of you ask me, what YouTube channel should you use? What the YouTube channel cannot teach you what I want to teach you. You can learn some skills, and I do not begrudge you from learning skills from some people there, but anybody can post anything on YouTube channel. And but I want you to be very clear what we are trying to do. Even if we use our time well, the ultimate goals of this course require continued dedication from lecturers and students to achieve it in the end. You should all become engineers that the goal is that you should all become engineers that are able to visualize problems of product creation and use deep engineering analysis on them, mathematics, numerical procedures, optimization, and so on. All these ought to lead to improvement of lives in our nation because you'll be able to actually set the uh, process of making products in the correct way. You should also become people that no matter where you find yourselves, no matter what the world turns out to be, you should have so many skills that you'll never be idle or jobless. That is the second goal. The third is that look at the fact that this course combines 3D modeling with Python scripting, and it opens the door for you to use the internet and other resources to continue a life of learning. So you can learn as much as you want from YouTube, but it will not replace what we are doing here. So you cannot take a YouTube course that will replace what we are going to do here. You do as much YouTube as you like, but you need to pay attention to what we are saying here because there are things here that you will not likely find on YouTube. Facilities provided by this course. The slides for everything that will transpire in this course will be provided for you shortly before each class. We failed that today. The slides were not ready on time, so I will make them available at the end of today's class. Such slides include video clips, diagrams, and practice facilities that you can use offline. AI-generated summary of each class will be available within 24 hours of completion. So now we have AI summaries. I hope you will be receiving the AI summary of yesterday's class. It is quite good because it summarizes what we did very neatly. Video of the class is also available. Let your class rep liaise with Mr. Yoade to make sure that that is available to everybody. You are encouraged to use the chat room, and I am there to personally answer your questions and view your comments and concerns. I will do that at the intermediary session of about 15 minutes. I will go to the chat room, and I will spend at least another 15 minutes at the end of the class to see whether there are still questions that were not dealt with during the time. I notice positively that some of your classmates will also try to answer you, which is very good, very healthy. You will discover that you will learn more than YouTube. You will learn from your classmates as much as you learn from your lecturer. I believe in your classmates more than I believe in YouTube. I believe that serious students who are pursuing this course will have a lot to share with you about this course. So in the chat room, your participation can earn you bonus marks. In my courses, there are no free marks. I don't give free marks. I'm very stingy with marks. No free marks. If you want bonus marks, earn them by participating in the chat room. That is a guaranteed area to get bonus marks. If you participate well, you'll get 5 bonus marks at the end of the course. So that will take care of your being on a borderline of anything. If you don't have those, if you don't earn those bonus marks, you will stay on your borderline, whatever it is. Transcripts of your participation are available to me always. And I know precisely which of you are attending class, and I know precisely who is participating in the discussion. I know those who don't attend class at all, and usually they don't do well. So when they don't do well and they send emissaries to me, maybe they know people that know me closely or whatever they do. All I do, I just present those people with the evidence of your participation. And once I do that, they just stop talking because they know that you earn what you deserve. Because I am going to spend time to do my own work. It is up to you to spend time to do your own job. And I'm not going to reward laziness. I'm not going to reward idleness. And I'm not going to reward somebody who just does as they like and think that they will get results as a result of that. It's not going to happen. Simple solid creation. Today, we begin with simple solid creation and move on to more complex stuff that are of practical nature, of a practical nature. Remember that we are not simply creating fanciful drawings. We have simple and straightforward objectives. Create actionable graphics of engineering designs. A graphical creation is actionable. You see, I say create actionable graphics. What do I mean by actionable graphics? A graphical creation is actionable if it can form the basis of simulation, engineering analysis, and design optimization. So the dimensions must be specific. All the materials given materials used must be known. All their interaction, the solid interactions must be known. And that's what we are trying to do with FreeCAD. We are not just doing general drawing with FreeCAD. Fancy drawings and renderings are not forbidden. If you like to do fancy, FreeCAD can do fancy. FreeCAD can do rendering. FreeCAD has a rendering workbench. FreeCAD drawings can be taken to Blender and render, and you have very nice drawings. But these are not our direct goals. I want to say that again. Fanciful drawings are not our direct goals. There's a render workbench, but we shall not have much time for it. You can post-process your work in rendering packages such as Blender, but that is not what this is about. I am saying that because of experience. Presenting me with beautiful drawings and failing the course. Each year, students fail this course because their emphasis deviates from the goals of the course. Such students, if they continue in their quest, can still make it in life by pursuing an artist's career. There's nothing wrong with that. They can even make more money than engineering. So I don't begrudge you. It is just not our goal. I am not an artist and I was not employed to teach you fine art. That is not what I was told to do. That's not what I am equipped to do. That's not what I know how to do. Don't misunderstand me. Modern artists often combine mathematics, Python scripting with rendering and blending to achieve masterpieces. This can actually be your destination as you do this course. So that may be where you are going. In fact, the person who taught me how to write Python in Fusion was an artist, a fine artist. And the amount of mathematics the fine artist knew blew my mind. He was able to, he knew graphics, he knew geometry, he knew mathematics, and he could program. If I can find that person, it's just that he did it in Fusion. So it's not very useful here. So there are fine artists that are really wonderful, and you might be somebody like that. So I am only saying that it is not my purpose to help you with that. I cannot forbid you from taking that direction for your life. But in this course, I do not have the time, nor the knowledge and background to help you in that direction. To do well in my course, follow our stated goals. If you don't follow the stated goals, and I'm telling you early enough, if you don't follow the stated goals, you are responsible for whatever you get at the end of your own journey. So let us just start today with very simple things. Let us create additive pipes. You can create a pipe. I will do this as an example here because it's very simple and something you should do. I want to do simple things so that the people who are just coming here will not be overwhelmed and say, it's only hard things they are doing here. We do simple things. And every hard thing is a combination of those simple things. And you will see, and you will see before the end of this class, while we were doing some simple Python talk yesterday, you will see that the talk of yesterday will not end with Python. It's going to come to graphics, it's going to come to modeling, it's going to come to simulation. You are going to continue those Python scripting throughout your engineering career. In fact, because you can do Python scripting, you are going to become a much better engineer than somebody who cannot do Python scripting. You will be much better, much better. And you will see that as we are moving on today. And in fact, you will learn more Python in this course than you will ever learn Python. You will learn more Python in this modeling course because we are going to do a lot of programming in this course once you are able to cope. Once I see you are coping with it. But before we go on, let us just fire up FreeCAD and do a very simple sweep creation. So I want to do that now. Let's see. I want my FreeCAD. Where is my FreeCAD? I'm launching FreeCAD 1.0.2 for this purpose. Okay, so we can start a FreeCAD session with a new body, and we can start the sketching. Can start with the sketcher, and in this case, let us start a sketch on the XY plane. On the XY plane, we can start a simple sketch. And the sketch I want to do here, I want to do an ellipse by center. So I start with the center here. And then I want the ellipse to have a 50 major axis, 50, and then 0 inclination, and then 30 minor axis. So the ellipse, as I defined it, is fully defined and it turns out green. So I close that. So around this point, I want to create a circular profile around this point. So that will be on the YZ plane. So I will close this and I'm going to start my next drawing on the YZ plane. So I will take the YZ plane, no, it's not the YZ plane now. It is the XZ plane, really. On the XZ plane, I'm going to do a small circle, a small center circle, create a circle by center somewhere around here. And let that circle be of diameter 7. Constrain the diameter to about 7. And then let it be a distance 50 from the center. If I choose it as 50 for the center, it will coincide. The horizontal dimension will be 50. That is from here to here. I want it to be 50. So that is also green. And if we close that and go home, so you can see here, you can see clearly that the ellipse is here. The center here is intersecting the ellipse at right angles. That is, the normal to the circle is a tangent to the ellipse. So they're at right angles to each other. So from that, I can create an additive pipe. And I said, create additive pipe. So it already knows that the profile is sketch 001 that is going to use. That is the profile I chose. So it's now looking for the object. So I can choose to add edge. And I can choose the edge. As I chose the edge and I click OK, you can see that this has given us, you can see this has given us an additive pipe along that. So that is okay. So let us change that profile to, say, a square. We want to change that profile to a square. We can go back again. Let us delete this one. Let's delete it and go to the sketch, go to the original sketch again and say edit sketch. When I edit sketch, no, I don't want to edit this one. So let the path remain unchanged. Close. Let us go to the path that created the profile. So I want to remove this profile. Remove that profile. Instead, I want to take a center rectangle. I want to create a center rectangle here. And I want the center rectangle to be 7 by 7. So it's 7 by 7. I now need to also specify its distance from the origin. So I take distance from the origin, horizontal distance from here to here. So I want that to be 50 as before. So again, it is green. The sketch is green. The sketch is green. The path is green. Let us look at the path. Okay, let us see. Okay, so let me close this. Okay, so if you look at the sketch, so again, just like before, so I can now say again, create an additive pipe. If I say create an additive pipe, it knows that it's sketch 001 that is supposed to be the profile. It's saying that here. So what it needs now is the edge. So I add the edge, and when I'm happy with that, I say okay. I click OK. So you can see again, what you have here is the same thing, but it's now swept a square all around instead of when it swept a circle. So there are simple things you can do like this. So another thing we might want to do is to rotate its profile. If we want to rotate a profile, let us delete this one. Let's delete this one. Delete the sketch. Delete the sketch. In fact, let us delete everything and start afresh. Close all. Okay, so I create a new body, start from scratch. I create a sketch here. In this sketch, I'm going to start on the XZ plane. I start on the XZ plane, and I want to choose a, I want to choose here a polyline. Suppose I take this polyline up here, vertically, horizontally, and vertically again, and then back there. So what I want to do now is to make sure that this also is horizontal. So I can come here and take the horizontal vertical and make this horizontal. Well, let me try my luck. I can do this and I can revolve this around. If I say close, I close that and I can say I want a revolve. So that revolve, it created this annulus by revolving that around the coordinate axis, the z axis there. So that's how you get that. So if I don't want that, I can do something else. I can come again and cancel all of that, close all, discard that drawing because it's simple, and start again with a new there, start a sketch. I love the XZ or YZ plane. So let us look at the XZ plane again. I can come here, I can take here a polyline. The polyline here can go up. We can do bevel here, get down there, and close it up. No, it didn't close. Okay. I want it to close, so I'm going to mark these two. I want to mark these 2 points here. I want to make them coincident. Okay, they have become coincident, and I want to make this one vertical. This is vertical. Or perhaps I shouldn't even make it, I shouldn't have made it vertical. Let us not make that vertical. Instead of making it vertical, let's make it a little bit complicated. Okay. So, let us say that now I want to rotate that. So you can see what I have created is not just a simple cone, but something with, so you can see there are simple solid making facilities that can create all sorts of things. And in a very short time, you can create something that from seemingly simple sketches, you can create something that becomes significant. And let us edit this revolve to show you the alternatives we have. So I can say that I don't want it to revolve through 360 degrees. I want it to revolve through 150 degrees. So, see what it looks like now. So that is when I don't allow. So the revolving doesn't have to be complete. Can revolve partially, and then you get this kind of thing. So there are simple, so you can have additive revolves. We will see subtractive revolves as we go on. And we will see that we can use our sweeping to create reinforcement rods through our design. And some of those things will work. Sometimes when they don't work, you may have to resort to programming in Python. Okay, so those are some examples. I want to go back to the class notes and move on. That is okay. So let us go to the slideshow now from the current slide. Okay, so from the current slide, we move to the slideshow. So you can see, I gave you the steps here. You will get these steps. You will get the video, and you will get the slides. So you can practice with some of them. You can again go, as some of you have been doing, go to the web. You will see some more complicated things that people will do. But please remember, we have our specific goals, and they are not likely to be met by just watching YouTube videos only. So you can repeat the same process and changing the profile, as I said here. In this case, this was what I used before, but I changed it here. So there are primitive solids provided for in the graphics environment. This can be created easily from the body making facilities, solid making facility. Here, let us make the cylinders and cones, and we've done more than that. And then I'm sure you can see that creating a solid cylinder is a piece of cake. There's nothing. And then creating this cone is again very easy. When you don't create it at the origin, it puts a hole in the center. And when you don't make the second part there vertical, it creates something a little bit more complicated than that cone. So let us now go into a more serious project of what I gave you as a homework last week. I started with those two simple things to just show you that you do not have to start at the deep end. You start simply, and you can see that virtually every other thing that becomes complicated is just a sequence of those simple, simple, simple methods. There is nothing so serious about them. Okay, so let us see this one. Uh, Subtractive revolves. I will just show you additive revolves. Last week, we were challenged to try our hands on the seemingly complicated object shown here. This is the sketch. We showed that object at the beginning of today's class. Let me just show you the object if you have forgotten. This is the object. This is the object. And then we want to see. So it involves 14 cycle or path circles and several tangential and dimensional constraints. After obtaining the basic sketch, we proceed to get a big part out of it. This part will now be taken through 2 steps of subtractive revolving. I've showed you additive revolving, so you can now see when it is subtractive revolving, it's the opposite of it, but the same process to get the final product. Yeah, when you finish that sketch and you get everything green, which is it's safe to get it green and fully constrained. What do we mean by degrees of freedom and full constraint? When you degrees of freedom are still degrees of uncertainties about your drawing, things that are changeable, things that you have not told FreeCAD precisely what length, what angles, what radii, what diameter, what vertical distances that they should have. So those are degrees of freedom. When you specify everything in a consistent manner, your drawing is fully constrained. When it says fully constrained, it's a euphemism of saying your drawing is fully defined. So instead of fully constrained, understand that to be fully defined. Your drawing is now fully defined. When your drawing is fully constrained, it is fully defined. And when it's fully defined, you need your drawings to be fully defined for simulation, because in simulation, all the dimensions will be exact and there will be no ambiguity. It's resolution for you. So when something still has degrees of freedom, it has degrees of freedom to choose the wrong thing, to choose another thing. So you remove the degrees of variety. Sometimes your system is over constrained. I'll show you an example of over constraining shortly. And so let us see how it goes. Adding slots and some other things. Let us move on here. And let me see whether I've recorded this, and let's see whether I can make it play and you can hear it. If you can hear it, then I won't need to talk. I'll just go on a break while you go through it for the next 20 minutes. There are 2 videos that you will get. They will both together, put together, they will play for 20 minutes.
We're going to begin our drawing today by drawing 3 lines from the origin, and they will be construction lines. So we begin in new document, and in the new document we begin the sketcher on the XY plane. On the XY plane, we're going to take our line tool, take the line tool from there, from the center. It's not really at the center, so let us see, from the center go up, and then back again at the center, go down sideways there, another one at center, go down sideways this way. Now we want to make all those 3 lines construction lines, so we take the construction geometry. So we are going to turn this one, and this one into construction. So they are construction lines, and those construction lines must be at 120 degrees to each other. So we take the constraint angle, the angle here, and the angle here is 120, and then the angle here, this to this, is also 120. Want the length to be 80, so take the constraint for length, the dimension at 80, here to 80, and here another 80. Okay, so with that 80, 80, 80, next thing I want to do is to create a center circle, also in that same way in the construction phase. So take a center, and it will be 50. Now we want to draw real lines now. They will be center arcs. So the first center arc starts from here, and it's like this. Another center arc from here. It is like that. And bring it down to do a center arc from here, and it will go like this. Now center arc, center, like this. So we want to join these arcs with another arc. Now a 3-point arc. Create arc by 3 points. Start from here to here, like so. Start from here to here, like this. Another one from here to here, like this. Okay, so those are the center arcs. So let us now take the tangency constraints. Our tangency constraints begin from here. This and this are tangents. Okay. This and this are tangents. This are tangents. Then this are tangents. This tangent. And these are tangents. Okay. This and these are tangents. Okay. This with this is a tangent here. And then this and this are tangents. Okay. So the next thing, we apply radial constraints to the end arcs. So take a radial constraint. So we constrain this at 20 here. This one also at 20, and then this one also at 20. So with those constraints, everything is now green. Next, we want to put a 30mm diameter circle at the origin, a real circle. So take it, make sure you are at the origin, and let that be 30. So again, because it's turned green, so that is 30. The next thing we want to do is to create slots at the 3 arms. Okay, we start with this slot here. Let the slot start at this end here, and let it come somewhere here along this line. Let another slot be here, and let it remain along this line. And the radius is 4 for now. The last slot here along this line, radius of 6. So we want all the slots to be tangential to the center circle there. So we take this one tangent here, this one tangent here, and this one tangent there. So what we want to do next is to change the radius of this radius of this, to be something, and let's say the distance from here. Let us constrain the radius and see. Constrain the radius here. To be 6. And the radius here to be 6. So we now have a fully constrained sketch. As you can see, everything has turned green.
Okay, so we continue now. So that is what we have here. And you can see, I will at the end, maybe in the next session, after your break, I will be able to add some other ideas to what you have here. And I am wondering whether I should go to, there is another 10-minute video. If you watch another 10-minute video, it will be 10:55. Then you can take a 20-minute break. You can take a 10 minutes, a 20 minutes break after that. So let us go on.
Let us now close our previous sketch and we get something like this. And because everything is green, it is an easy thing for us to do a padding on this sketch. A padding, as usual, we have just a constant figure of 10. So we want that to be 80 millimeters. So let us make that 80. And we don't want it to be symmetric to the plane. 80 is okay. So let us just accept that. Okay. So you can see now that we have a thick pad there. And that thick pad, all we need to do to get something that is looking like what we wanted to get at the beginning is to just do a groove on top and the bottom. FreeCAD calls a subtractive revolve a groove. So it's a subtractive revolve in Fusion or some other packages. But let us just try and use the word groove here. So in order to create our groove, we must again do another sketch. So let us say we do a sketch. What is the best plane now to use? I choose to use the YZ plane. We can use any plane to do this groove. And let us start with a polyline, or maybe let us just start with a line. We can start with a line here, and then the line comes here, and then take another line, or take another line along here, and then comes from here, here, now let me first of all hide the pad briefly, and I want to do a 3-point arc here. So I want an arc that goes from here to here, and let the arc be like this. And let me just put a circle around this point here. I want a center circle around here. Let that center circle be 5 millimeters in diameter. And then let me make it bigger, and I'm going to do some trimming there. So I'm going to trim it like this, like this. So I want that to be a little bit bigger. So let me make it 7. So 7 instead of 5. If we're happy with that, we say okay, and we close. There are 7 degrees of freedom, but this is a case where we are going to ignore it. And now let us bring the part back. And now, so let us say we want to do a groove, and let us see how the groove will look now. Let's see the groove, groove, groove. Okay, so you see my groove. The groove is funny. So I'm going to make some. You can see that I didn't go far enough in the extent of that edge of the sketch. So I'm going to say okay here, and I'm going to modify the sketch. Edit the sketch. I'm going to move this much further away, and I'm going to move the center of this some distance away, and let us accept that and see what that does to us. So you can see that we can play with this now. We can play with this. See us having the kind of effect that we were looking for previously. We can do the same thing at the bottom. We can create another sketch. That sketch can still be on the same YZ plane. And when we're doing that sketch, we can just do straight lines, straight edges this time. This one. Okay, maybe do a polyline from here to here. Okay. And close the polyline. And now, to make it a little bit fancy, go to the model tree, and let us just rub off the groove for now. And here again, I can put some circle, and then put another circle, and let me just put a square here to just make it interesting. So what I'm going to do with this is that I'm going to make this one go inside. So I'm going to trim. I'm going to do the trimming in a funny way. So let us do the trimming. Here. We're going to do this trim here, here, and then we're going to trim this to come out here, 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 and here. So bring back the groove, and now we are going to do let the axis be 1, and this is 0. to see the rotation. You can see how it rotates. So if it is rotating and cutting that way, okay, so let us see if that does it. If that does it, and then the next thing is, let me try the groove again. Okay, so let us see what is happening under. You can see what we have made, and I'm sure that you can play around with this and get all sorts of features on this thing, make it that thinner, and that is it. Something
Okay.
that looks so difficult is no longer that so.
Okay. So I'm going to give you a break now. We're going to take a break of 20 minutes. Based on some of the comments in the chat room, I'm going to redo the slots on this diagram. Some people wonder whether there is a slot creating icon in FreeCAD. Yes, there is. In fact, that's what I'm hovering my mouse on right now. There are two actually, create slot and create arc slot. There are two of them. So I've not tried create arc slot, but I use the create slot in this drawing. I'm going to use it again. So there are two of them. You can use them. Second thing is that as we continue using Python, you will see that you yourself can create things you don't see there. You can create and make them part of the things that can be used. That's the beauty of being able to, when you can do Python scripting, you can do so many things and you can even change FreeCAD to your own taste. So that is just imagine when you are in that position, how powerful you are and the kind of things you are now able to do. So that's why I'm introducing you to this power. Once you start, you are in 200 level. If you continue trying and you are not lazy, if you work for 4 years, you shouldn't be at this level 4 years time. You should be able to do things that will amaze your mates in Unilag and your mates anywhere else by the time you are on youth corps. But you have to continue. You cannot just lazily sit around and expect things to happen. So what I'm going to do, I'm going to create these slots again, and I'm going to use a completely different method. So what I will do is that from this sketch, I'm going to rub off the slot. So I'm going to take the slot off. I'm not able, okay, let me just see it. Well, let's edit sketch. Yes. Okay, I'm taking that off. Taking that off. That off. I'm taking this off. This off. Taking this off. I'm taking this off. Taking this off. This off. This off. And this off. So this drawing is still fully constrained. So what we're going to do now, and you know how to arrive at this point, so there's no problem. We're going to do a padding of this one. So we're going to come here and save and close up. And after we close the sketch, the pad is still there. And we can do our grooving and whatever. So let us see another method of creating the slot. The next method of creating the slot is that I'm going to do just one slot. So I'm coming to sketch again. So I will take a new sketch. And that new sketch is going to be on the XY plane. So in this new sketch, I want to select some, I want to hide the part, but I still want, I want to show the previous sketch, and I want to bring in external geometry. The external geometry I want to bring includes the center. I want the center of this. I only need one center, but at least you can see somebody was asking me, how do you bring in external geometry? And then there was there was a line, there was an arc, a construction arc that was about 50 at the center. So I want that back. So I want that arc to be drawn. It's 50 at the center. So that one is still there. I need that. So, so with that, I now go and choose my slot. So I want the slot to start from this center here, and I want it to go down there. I want the radius to be 6. Okay, but I want the slot to be full line. So I will take this and I'll take this and I will apply it to this slot. So I have the slot done now. Okay, this is still not showing. Okay, so I have the slot. First of all, I want the slot to be tangential to this. So I want to take the tangent. So it's tangent to that. I want to be sure that the radius is 6. Let me just check. Constraint radius. It's already fully constrained. So let me just check what this radius is. I'm not going to do anything. Okay, cancel. So that is fully constrained. So let me close that drawing. Now, I want to select the part. I want the part to be visible. I want to create this, and I'm going to create a pocket out of that. And I'm going to create that pocket in such a way that it goes through everything possible, through all. So, okay. Well, that is not successful. So what I'm going to do, let me turn it around and see whether I can do it successfully. Okay. I That's a mistake. So let me just correct that mistake straight away. I want to remove, let me close, let me just turn that off, delete. And the sketch 001, I want to delete that too. And go home. So what I'm going to do is that I'm going to select this surface. I will select the surface of the pad and I'll create sketch. So my sketch now is not on the coordinate plane. It's on the surface of this pad. And in order to start, again, as before, I need some external geometry. The external geometry I will say, bring in external geometry. And the external geometry I need includes this. In fact, this is the only external geometry I'm interested in, that center there. And then I want to create, I want to create a construction circle at the center there, and it's 50. So that is okay. And I want to go back to ordinary drawing. Again, I choose my slot, create slot. And I want my slot to start from this center. That is why I choose that center geometry. And I want it to be tangent. I want it to be tangent, but it's not agree. So let us just choose it. And then that is there. Now, I want to select it so that it's tangent to this. So I want this to be tangent to this. So it's tangent. Now, I want to choose the radius. I want to constrain the radius of that slot. The radius of this. I want that radius to be 6. Okay, so you can see as before that my slot is fully done. Because my slot is fully done, I can close. So that slot is there. You can see that we created only one slot now, not three. And we did not create the slot with the sketch of the other things. We created the slot separately and we created it on top of the pad. Those steps are very crucial to achieve what I want to achieve now. Now, imagine, like I will show you some pictures later, there are only 3 arms here, but suppose there are 5, suppose there are 7, suppose there are 9, and I want to create the slot. Would I have to be creating them one by one? This is the trick to not need to create them one by one, to create one. If they are the same slots all through, you can just replicate them. So what you are going to do here is that you are going to do a pocket. You can see a pocket is done to 5 millimeters. You want the pocket not to 5 millimeters, you want it to go through the entire, to go through all. So this slot has gone through. So you can see that by rotating this and see that it is gone through the entire from beginning to end. So if you're happy with that, just click home. What we are going to do next is that we're going to choose this pocket that we have just created. This pocket. You can see the first thing is that the pocket is now different from the pad. In our original way, the pocket was part of the pad. This part is the same thing. But here, the pocket is different from the pad. So what I'm going to do, after selecting this pocket, I am going to, okay, let me just say, okay, I've finished creating the pocket and I'm selecting it. So I've select the pocket. I'm going to come here and I'm going to select the polar pattern. The polar pattern I'm going to select is going to be, uh, I'm going to select polar pattern occurring 3 times. And it's already, you can see, it has already created those slots because if you divide 363 times, it's going to be 120, 120, 120. If there are 5 slots and the things are at 72 degrees, I select 5, it is going to put them there. So you can see that instead of creating it here, creating it here, and creating it here, I just create it one, but I must make sure that it is occurring on its own. It is not part of the pad. So when it's not part of the pad, I can say okay like this, and you can see again that I achieved the result of the previous step without working as hard as I did in that previous step. So how do I answer your question? To people who are wondering, is there a slot icon? Yes, there's a slot icon in the sketch. And does it create slots? It creates slots, and there is something there that can even create arc slots. So those things you can do. So I go back to my notes. We only have about 25 minutes left, and I still have a lot of things to do. So let us just go back. Going back now, I'm on slide 15, and I'm now, let's see, what is this thing that is disturbing me here? Okay, slideshow from current slide. Okay, so this is again the same thing, the same idea with 5 slots. You can do, like in this case now, just like what I just showed you, I only created one, made sure it went through, and made 5 copies of it, and it will land at the correct place because they are all equal angular, so there's no problem there. So FreeCAD gives some relief to a number of repetitive processes we went through above. It is instructive to create a slightly more complicated drawing that is simply more of the same. It is a place where the repetition of the groove becomes, I want to say slot here, of the slot becomes even more boring. We shall therefore use the advantage of polar patterns to relieve some of that. Uh, we can easily make it more complicated, 7 groups, 9 groups. When faced with such repetitiveness, there are 2 strategies that can help: Python scripting or parametric drafting. Okay, we're choosing parametric drafting here. Let's look at how drafting can do it. We find time later to explore Python scripting. We'll see some Python scripting before the end of the class. That's why we are having that class in parallel, not to increase your problems. Okay, so this is the sketch here. Like you see, the sketch did not include any groove. There's no slot in this sketch. So it is plain. So because it is plain, we now create one slot the way you saw me do it. It's a strategic move here to remove the slots from the pad. If we don't, it will it will not be possible to create them in a batch as we now do. We come back to do a new sketch. Instead of doing it on the coordinate plane, we shall do the drawing on the surface of the part. That was a mistake I made previously. We have to do it where we can see it on the surface of the part. Otherwise, the padding, the pocket will not work. This means we shall select the surface before clicking the sketcher icon. So don't ask me, how do you do that? Select the surface first, then select the sketcher icon and to assume that the attached surface is the surface you have just chosen. That way, the initially selected plane becomes the plane to which the new sketch is attached. Okay, that is the end of that. The next thing I did is that I started doing the drawing of the bench, of the concrete bench. I have done some measurements. You go and do your own measurement. Don't use my measurement. You can play with my measurement and see that it works. Go and take your own measurement. And sometimes I just did this as a rough thing because the thing bends backwards here before going down. So I'm going to I'm going to mark you depending on how close you are to the actual thing. So this is one thing. And I decided to do this drawing. I'm rushing through this because I'm not going to, I don't want to end my today's class here. Uh, I did this. This is the end. And then you can see the places where you put the back end and the bench. All those ones are already there. And then the next thing is to put the reinforcement. The reinforcement is a sweep. That sweep is trivial to do in Fusion. When I was doing this infusion, it did not involve any pain. It is a pain in the neck to do sweep through polylines in FreeCAD. In fact, it can be frustrating. And the only solution me I can see is to write Python code. And this particular one, I didn't get it until I wrote it in Python. It looks so simple, but I had to go through Python to do it. And I will introduce you to a more elaborate way to sweep and do Python code today. And I will correlate it with what you are learning in the Python tutorials I've been giving you. But we'll come back to this. Just know that we can do the reinforcement by Python. I spent hours trying to just sweep around this polyline. How did I get the polyline? Again, I got the polyline by Python by offsetting the external profile. FreeCAD does not provide an offset tool like Fusion, but you can get it again through Python scripting. Anything you want. If you are ready to be patient and you can do Python scripting, you will get it. And when you've gotten it through Python, it remains yours forever and you can use it over and over again. So the advantages that Fusion has over FreeCAD can be overcome with Python scripting. Okay. You may not be able to see what is here, but when you receive the slides, when you look carefully, you will see how this path becomes the direction uh, of one of the reinforcements. And it is good because when you go to the simulation tools wants to see the reinforcement as a different body, even though it will be included inside the concrete structure. So we will get to that later. Now, I want to end this class. We have about 20 minutes to go. I want to end this class by taking you through a sweep script. What are you going to do with this? You are going to type and copy this script line by line. There are up to 60 lines. Just we are going to spend the time. But what I'm going to do in this class is to explain what virtually everything in the script means. And I want you to correlate it with what you have been doing in the Python tutorial. You will see that if I didn't take you to the Python tutorial, you would have just been lost completely today. So last week you got a script that created a path for 3D sweep. Today we shall do a similar wire path and actually sweep a circle through it. Your assignment will be to modify only the profile section, and see what you can sweep with another profile, say a square along the same path. You remember we did that earlier when we swept a circle through a profile and through a path, and then we came to sweep a square through the same path, and we got different shapes out of that. The code has 5 sections, and the line numbers are provided to ensure you enter them correctly. I have come up both with the line numbers of the code and the line numbers of the comments so that you can get these things put together. It won't cost me anything to give you the full code so that you can just cut and paste. But you learn nothing when you do that. When you type it in, you will know the blood, sweat, and tears of actually writing code. Everybody who knows how to code goes through that blood, sweat, and tears to be able to get things right. You cannot get that on a platter of gold. You have to go through the painstaking way of typing every line word for word, understanding what they mean, and getting used to the patterns they create. Okay, so the goal of the script is in the preambles. Portions of FreeCAD API that do the heavy lifting are made available to our script. When looked at objectively, you discover that programming the API is simply looking for the objects that are designed to do the work. What will do the work is already pre-programmed by some other people. Your duty is to call them in the correct order, pass to them the right arguments, and your job is done. This commences with the importing of the relevant portions of the API into your script. So you see lines 1 to 4, 5, and 6 are either empty or comment lines. Okay, so sweep of a circular profile on a wire written by O.A. Fakinlede, date December 8, 2025, FreeCAD API. This may look unimportant. It is a good idea from now to always comment on your program at the beginning of it. State when you did it. State what you are trying to achieve. Believe me, the program, if you wrote a program 3 months ago, when you yourself look at that program, you will not remember what the program was about. The only thing that will help you is that you have made some comments on it that will remind you what you are trying to do, when you did it, and how you did it. So the first 6 lines are not trivial. They are part of what you need to do. So line 7 and 8 say import FreeCAD as app, and then import path. Both lines can be the same thing. You could have said import FreeCAD as app, comma, path. That 7 and 8 could have been a single line. Then I asked, what are lines 11 to 12 doing? What happens if they are removed? I will not tell you the answer. What I will challenge you with is, after you have made it run, remove it, and you tell me what happened. And you now tell me next week what you think lines 10, sorry, not 11 to 12, 10, 11, and 12. You tell me what they are actually doing. Sorry, I was right. Just 11 and 12, because line 10 is critical. But line 11 and 12 is ignorable. And there are situations where it can be ignored. There are situations where ignoring it will cause a disaster in your program. I want to see whether you can detect that on your own. So we have already explained lines 1 to 13. Line 14 starts with, line 14 says, start with points as an empty list, create points from vector tuples, and append one by one. End with an ordered list of points. I want to go to the chat room and I want to ask a question. The question is this. Last week, I gave you code to type in, I want those who actually typed it in to indicate so in the chat room. Did you type in the code I gave you last week? If you did, let me know in the chat room. I want those people who did it in the chat room last week, who did it last week, to tell me in the chat room. I want to know how many people actually tried. Please be careful, be quick. If nobody answers, I'm going to assume nobody even tried it. Okay, I did, sir, but it didn't work. That is Toby showed that day. Sir, was it the one from the Python class? It wasn't in the Python class. It was in the FreeCAD class. It wasn't in the Python class. Anybody else? I've only seen two responses to the question. The question is this: I gave something to you last week, and I want to know whether you tried it. Ikulamberu said, was it the one from the Python class? He doesn't even know. He's still sleeping. He didn't even know where he received instruction. I was unable to import NumPy despite installing another version of Python 12. It, 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 it is not running. Sir, can you explain how to make the code run? So be sure that did you try it? Okay, you are the person that said you tried, it didn't run. Can I explain how to make it run? I did, but got a lot of errors. Some my mistake didn't run. I was using Visual Studio Code, so it didn't respond properly because I wasn't using Jupyter. I tried, it didn't run. I used VS Code. I tried, but it was bringing errors. Almost every time, even cross checking, it didn't run. Hmm. Okay, so let me just check whether I have access to that code and I can quickly make it run in your presence to see that it's not magic. Let's see. Because where's my free card? See here. So let me close everything. So what I want to do here is to check for my macros. Let's see whether that macro. Uh, I'm trying to get the macro and see whether I can make it run. Because if you do not believe it will run, then I'm wasting time just telling you again about it. It's supposed to run. So let's go back to free card here. What do I want to do here? I want to go to macros. Let's see. Um, it's wheels called macro. I want to look, let me just do one more, make one more effort to see whether I can locate the macro, because I didn't know that I will get to the class and not one person has tried that macro. Yeah. Is there anybody in the entire class that tried and succeeded? Let me just try and see. If not, then we have our work cut out for us. I tried, but it was bringing errors. I think we all forgot. Pip install free card. Can you show us the step to type in the code? I should show you how to type in code. I should show you how to type. What are you asking me to be Shotade? Can you explain what you are saying? Okay, the way to type is that you put your finger on, if you want to type F, you put your finger on F and press it down. If you want to type T, you put your finger on T and press it down. If you want to type 5, you put your finger on 5. Is there any other thing you want me to show you how to type? What's a humongous question? So Ayomide Oluwatola, did you try it yourself before you teach others what to do? Have you tried it successfully? Ayomide. Adekunle. What did you say, Adekunle? Do you mean you did it? Adekunle, can you answer me? Did you type it in and you got it working? No, I've not got one person that typed it in and got it running. Adekunle, what is the meaning of your yes, sir? Did you type it in and you got it running? So what is the yes, sir, that you are saying there? So it means not one person typed it in and got it running. Well, I don't know. Let me see whether this new macro is showing here, and I will do it step by step. Hmm. Macro. Hmm. Let me just check this one. It's not showing. Okay. This is the macro for today. And this is the one I'm trying to explain now. This is the full macro. Okay, so let us see. Uh, let me execute the macro. This is the macro. I just got it in and executed it. This is it. So what I want to do, I want to just get the macro to the level where the one I gave you last week got and execute it only that far. So let me first of all decide to close all now and discard. Let us look at the macro here. Okay, so So this is what I gave you last week. This is what I gave you last week. And the difference, this is what you are supposed to achieve last week. And I'm going to recode it so that it will be exactly what I gave you last week. And let us just see how to do that. So let us go back to the macro. This was the result you were to obtain last week, but the code wasn't exactly the same. So let me make the code to be exactly what you had last week. I will edit the macro. Line only. This thing is too. Okay, yes, the line only is here. So I don't know how clear this would be, but I'm going to write the code the way your code last week was given to you. And there's a reason why I'm doing that. I'm going to copy this into this place. Paste, comma. Second one, copy, paste, comma, comma. The third one. Okay, what time do we have? It's past 12. So we will continue this next time, and I will send you this. This is what we are supposed to achieve. And this is the code that I gave you. And that is, there is a mistake here. There's a code, there is a point mistake at this point. This is exactly the code I gave you last week, and the code is working. I've recreated the code again, and this is it. It is working and it's running from the micro straight. So I will challenge the class for the next. I will do it in the next Python class. In the next Python class, go and practice what I've given you. If you don't practice what I've given you, we are not moving from that point because you are wasting my time if we don't practice it. This is the code and it is running. So we leave this. I will send you the notes of today's lectures to you, and we'll continue with this previous week practice. So I want to see more people that have tried and made it work before we move on. If we don't, then we're wasting our time. Thank you.